In this last lesson, we are going to look at permutations and combinations. And what is this? This is basically a mathematical tool that you are going to use to calculate probabilities. Permutations and combinations, they are just ways that you have to determine, better yet, they are a mathematical tool that allows you to determine the number of ways of selecting R objects from a pool, from a universe of N objects. Basically, to figure out the number of arrangements that you can get out of a universe of N objects. And you have two different options. You have permutations and you have combinations. Now, what is the difference between these two? Because there is, you have to press different keys, literally, in your calculator to get one and the other. If the order by which the events are coming out happens, or if the order in which objects are matter, then you have to use permutations. If this order doesn't matter, then you have to use combinations. I'm going to use the example of two different type of lottery games to illustrate one and the other. Let's say that you have and you need to calculate the number of ways in which a number, a ticket number, a lottery number can come out. In this case, the order of the digits matter, right? If you are to calculate the probability for you to get the first prize in this lottery, you have to first figure out the number of total arrangements that you have for the length, for the number of digits that the ticket has, right? So let's say that you have, for example, 7 different digits. Then the order of each one will matter, because only then it will eventually match the number, the full number that you have in your own ticket. So for that example, you would have to use permutation. All right? If you are talking about that lottery in which you just have and you select randomly 6 different numbers out of a pool of, let's say, 50 or 49. Here in Europe, we have Euro millions, so I guess that every single country would have their own variation of that. You receive the prize if, after the numbers come out, those numbers match the ones that you pick. In that case, the order by which the numbers come out, usually these are balls out of a big rotating sphere that come out. The order by which they come out doesn't matter, all right? As long as the number that comes out is the number that you have previously selected, then you are fine. In that case, the order not mattering, you will use combinations. And what is the mathematical tool? You have two ways of figuring this out. If you don't have a calculator, you may use the formula for each one. And if you have a calculator, then you'll have to look on it for the key that has something like NPR or NCR. In my calculator, if you're using one of these, I'm going to try to bring this closer to the camera. These are on top of these keys over here, the times and the division key, all right? So you just have to press Shift and then either one of these keys to use the tool. And how do you use it? I'll explain that in a bit. First, you need to know what the formula means, okay? So for permutation, you have here N, this is the total universe of objects, okay? And R is the number of objects that you are selecting out of this pool, okay? So you usually say NPR. So for example, 6P5, all right? This would be the number of ways in which of selecting 5 different objects out of a pool of 6, okay? And the formula is this one. So in this particular case, this would be 6 factorial divided by 6 minus 5, which would be just 1 factorial, right? As we saw before, for bigger numbers, this fraction will boil down to this, All right, so let's say, for example, that this is 10 and the r would be 3. So this would be 10 minus 3. It would be 7 factorial. So 10 factorial divided by 7 factorial is just 10 times 9 times 8 times, and that's it. Okay, then you have 7 factorial, which cuts with the denominator. Okay, so this is called permutations of R objects from a universe of N objects. And in your calculator, what do? You just press, I'm going to use the example again, 10, then shift, in my case, is the times key, which will give you the P. I don't know if you can see. Let me put it more over to this side. You cannot see it. Right, doesn't matter. It's 10 P7. Press enter, and you have a number. Okay, and this number is a total number of arrangements that you have for this particular situation. Okay, calculating combinations. It's similar. The formula is just this. In your calculator is just about the same. So 10 shift in this case is the division key to access the combination key, and then 7 again. So 10 C7. This will give a number. And if you try in your calculator, and I urge you to do that right now, figuring out the number of arrangements using permutations and combinations, you are going to see that the number of arrangements that you have if you use permutations is obviously always much bigger, using the same values of n and r, than the number of arrangements using combinations. And if you think of it a little bit, the reason is obvious. You will have many more possible arrangements if the specific order that you are looking for matters. If you look at the formula as well, look, there is a clear relationship between this and that. What is the difference between the two formulas? Is that this one in the denominator, you have whatever you have as r factorial there. Okay, so you will have a bigger denominator, which will yield a smaller number of the whole fraction. Actually, this means that if you want to calculate combinations, that is just the number of permutations divided by r factorial. All right. When you study the last chapter of pure math, binomial expansion, I'll talk about this more extensively. I put this here just more as a matter of curiosity for you to see the pattern. Okay, I just calculated the values. In this case, it was what? It was combinations from 0, 0 to 6, 6. Okay, so I put here the value of n, here the value of r, and then using the calculator, I just plug in the correct column and line the values that I would get. Okay, so for example, over here, the 6 means what? This is 6 combination 5, and the result is 6. Try it in your calculator, and you see that this is 6. All right? Okay. I can put these results that I have here on this table using this structure. This is called Pascal's triangle. And it's a curious triangle because if you look at it, you'll see that every single number can be deducted from the previous line. So take this 10, for example. This 10 is the outcome of adding 6 and 4. 6 and 4 equals 10. This 15 is the outcome of adding, the numbers that are on the top line, and to the right and to the left of it. So 5 plus 10 is 15. Actually, you can start with this one and get every single value that you have underneath. So you start with 1, then here, obviously, you have 1, 1. Then over here, you have 1 plus 1, that's 2. All of these is going to be 1. All of this is going to be 1. Then this is 2 plus 1 is 3. This is also 3, and so forth. All right? With this, you can see that the pattern, you have a line of symmetry over here in the middle, right? Take the last row, for example. This is 20. To the left, you have 15, 15. Two places to the right is 6. Two places to the left is 6 as well, etc. So you have a symmetry property. Whatever combination n r, whatever this value is going to be equal to the combination n combination n minus r. Take this example. Again, this is 6 combination 5. So 6 combination 5 is the same as 6 combination n minus r. In this case is 6 minus 5, which is 1. 6 combination 1 is 6th row, first position. Don't forget that this is position 0, which is that 6 as well. This happens to every single value, and you can test it. Another curiosity is that the one I just told you, that whatever combination you have over here, this is the outcome of adding the two combinations right on top of it. That's what this means. So, for example, this 6 combination 5 equals n minus 1, so 5 combination 4 plus 5 combination 5. 5 combination 4, 5 combination 5. Add these two, you have that. This is called the addition property. All of this can be used to calculate probabilities. So you're going to see another class of questions regarding probabilities for which you can use these tools. So take these as tools that you now know to operate in order to calculate probabilities.